Okay, so we're going to get started, not with that, with looking at the few problems that I posted. And I know those were some kind of basic, but I wanted to kind of go back. I started over Friday just to kind of make sure we're understanding. So, again, these are some common integrals that I'm going to have saved in case you want to reference back to them. I do encourage you to at least, commit some of these to memory. For instance, the something like this. Also, you know, this is one you want to, make sure you know. Um, oh, can y'all see? I think I forgot to. Oh, I am presenting. Okay, all right. This looks hard. Oh no, no, this is just common don't let this worry you. We're just going to use this as a reference. Okay. So most of this we've already looked at. It just wasn't all put together. So don't let this, we'll just come back and reference this as needed. So the first thing I wanted to do though was go over these five problems that I had posted. And so we were using use substitution. If you didn't watch the video from Friday and you feel good with use substitution, then you don't really need to go back and watch it. But if you are struggling, I did kind of start back at the beginning and walk through how to do it. So when we're doing this, you want to ask yourself, well, what is the inside function? So if I say for number one, we want to let u equal the 3x squared plus 1, then what is the derivative of 3x squared plus 1? And that would be 6x dx. Now, this 3x squared this 3x squared plus 1 is our u. So when we rewrite this, we have, maybe if my pen works. Mm. Oh my goodness. This is not the time for technology to fail me. All right, so this would be the integral of, that looks really bad. So we would have the integral of u to the fourth. And then what you notice is the 6x dx is du. So I rewrote it in terms of u, and now I can take the antiderivative. So the antiderivative says to increase your exponent by 1 and divide by the new exponent. So now what is the u? 3x squared plus 1. Well, this is not. Well, 3x squared plus 1 to the fifth divided by 5 plus c. And so I made the comment in the last class that use substitution is the inverse of the chain rule. So now for number 2, if we're looking at number 2, we need to identify the inside function. And one of the things that helps with identifying the inside function is that you want to ask yourself, well, which one, if I take the derivative of it, is also within the problem? So when I'm looking at number 2, I see that this x squared plus 5 is in the denominator. And if I take the derivative of that, it's going to give me a 2x, which is also part of the problem. So we go and say let u equal x squared plus 5. So then the derivative of u is 2x dx. Now that is in the problem, so that's going to be 1 over u, then du, because the 1 over u, and then, okay, y'all got to go in your room. I'm recording and I need y'all to be quiet. Okay, so 1 over u du. And so we talked about what is, when you have 1 over something, that's the same as that variable to the -1. And if we were to apply the common rule where you add 1, that would give us x to the 0, which isn't really a problem. But then when you divide by 0, you can't do that. So you would say what the natural log of the absolute value of whatever your u is. So this, for number 2, would have become the natural log of the absolute value of u plus c, and then you substitute u back into the problem. And so that is what you should have gotten for number 2. Now, number 3, if you want to identify your u right off the bat, that's fine. I am going to rewrite this in the form of an exponent, just because I think that when I start to rewrite it, that'll help me. So now, what would we identify u as? The 2x squared minus 7x plus 1. And so if that is our u, when we take the derivative of u, it should give us, if not exactly what was in our problem, a way that we can make that part of our problem. So that is u to the 1/2 du. U to the 1/2 du. So then when we take the antiderivative, you increase your exponent by 1 and divide by the new exponent. Now, when you divide by a fraction, that's the same as multiplying by the reciprocal. So that is 2/3. Replace your u. And you can leave this the 3/2. If you wanted to, you could rewrite that in the form of a radical, but I mean, I just think this is fine. All right. So then, number 4, we have e. And while at first glance, when we see e's, we might be like, But truly, when we're talking about derivatives and antiderivatives, they're some of our easiest problems. Now, when we look at this, we let u equal 5x minus 2. So then the derivative of u, the derivative of 5x minus 2 is just 5. Now, there is no 5 in this problem. So, this is where I think some people were getting confused about what do we put here to take place of the 5. Well, if you solve this for dx, you would see this is 1/5 du equals dx. I hadn't been showing that step because I was just telling you, whatever is in front here, you can divide it out. But if this helps, then that would be 1/5, and then you would put your du to take place of the dx, e to the u. So now, if we go back to our common integrals, e to the exponent is e to the exponent. So that becomes 1/5 e to the u plus c. And so then you just replace your u, and there's your problem. So this was one where it didn't have the entire dx included in the problem. And I think we had been doing that before, but I think maybe I moved a little too fast through it. So we'll look more at that today. And that's going to be similar in this number 5 with the integral of cosine 3x. So if we're looking here, we have the integral of cosine 3x dx. So our inside function is 3x. So then dx is the derivative, which is just 3. Not dx, the du. The du is equal to 3 dx. Now, there's not a 3 in here. So for me, I just look and I think, well, what's the opposite of multiplying by 3? Multiplying by the reciprocal. However, if you need to show that, that would be 1/3 du is equal to dx. So that would be 1/3 the integral cosine u du. Now, some of us may just remember the antiderivative of cosine is sine. If not, here's the common integrals that are listed here. So the integral of cosine is sine. So that is sine 3x plus c. And I'm so sorry that my pen is messing up. I'm going to order a new one, but I guess with the weather, things are not delivering to my house. So I'm going to order one, but I don't know when it'll arrive. But we shall see. So going over those few, how do we feel with those 5? Had anyone tried them before? Yes. Lucas, had you had a chance to try them? Okay, but the ones you did you understand? Yeah, we're going to do more today. Um, So we are going to do, I'm going to first go back up here to this, and I'm going to do a couple trig. And I don't know, we may have done some of these before, but I wanted us to look at some trig examples. So say I have sine 1 minus x times 2 minus cosine 1 minus x to the fourth. So now, when I look here at and identify my inside function, you could easily be like, oh, it's 1 minus x, but that's not going to take care of the sine and cosine. So you need to identify your inside function as the entire 2 minus cosine 1 minus x to the 4, not the dx part. All right, so then if that is our u, then the derivative of u is going to come from the 2 goes away. So the negative cosine 1 minus x. No, we don't want the fourth either. My goodness, Catherine, focus. Anyway, so the derivative of negative cosine. So if you look up here, the derivative of cosine is what? Sine. So this is a negative cosine. So the antiderivative of that is going to be negative sine. But when we take the derivative of cosine, oh, hold on. I just was doing the antiderivative. We're supposed to be taking the derivative. What's the derivative of cosine? The derivative, not the antiderivative. So the derivative of cosine is negative sine. And since it's negative, that becomes positive sine 1 minus x. But the chain rule tells us then we have to take the derivative of the inside function, which would be negative 1. Now, when we look at this u is u to the fourth. That's here. That all is taken care of. Now we look at our du. Our du is negative sine dx, the sine function. So which part of that is not taken care of in this problem? The negative. So you need to put the negative somewhere. Either you put it on the outside or you can put it on the inside. And so now the antiderivative of u to the fourth is u to the fifth divided by 5. So that's negative 2 minus cosine 1 minus x to the fifth divided by 5 plus c. What'd you say? Yes. 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 That was correct. Now, you can leave it like this, or you can pull out a negative 1/5 times 2 minus cosine 1 minus, oh my goodness, my pen. 1 minus x, I'm doing it again, to the 5th. Either one of those is fine. We'll do one more tree example. Then I want us just to kind of, I had posted those problems that I think I did like labeled it more substitution. So I did want to take some time to go over some of those. So say we have, let's say cosine of 5x, that's cosine, times sine of 5x to the 8th dx. Okay, so we want to identify our u, our inside function. So if we let u, we don't want u just to be 5x, because then we're going to have a cosine and a sine, and we're not going to have a way to get the derivative of 1. But if we look at cosine 5x or sine of 5x, which one of those is a composition? The sine of 5x, yeah. So that's going to be our u. And so if that is our u, then we say, well, what is the derivative of u? So the derivative of sine is cosine, and then the derivative of 5x is 5. That's using the chain rule. So now, I have a lot of this. I have the cosine 5x dx, cosine 5x dx, which is the du, but I don't have that 5. So to take account of that 5, I have to multiply by the reciprocal. Now, I need to deal with this part. So this is just u to the 8th. So 1/5 times the antiderivative of u to the 8th. So now, the antiderivative says I increase my exponent, divide by the new exponent. So if I multiply the 5 and 9, I would have 1 over 45 u to the 9 plus c, which is 1 over 45. U is sine 5x to the 9 plus c. Now, you could also write this the 9 like that. Whatever, I mean, either way is fine. If you were to like ever see this written somewhere, it would be written this way, but they're equally as equal. All right, so let me find, I had posted some problems, more substitution. And so just kind of to show you what that looked like, if you can, it looked, I don't know if y'all can even see this, but it looked like this. It's in Canvas. I could probably try to pull it up to show you what I'm talking about. That would be a good idea. So in Canvas, more substitution. It was probably this practice substitution. So yeah, more substitution. So we never went over these, but this is what I want to look at now. And because let's see what is going on with the screencast. I am going to actually stop recording because the recording only is going to last like 30 minutes. So I'm going to make a new one. I'll start a new recording going over the more substitution so I can I'll post them separate. Oh, it didn't